At their most foundational level, computers run on electricity, and we have to be able to find some way to control that flow of electricity. When computers were originally created, we used relays, which were just manual switches that you could turn off or on the flow of electricity. And then we graduated to the use of vacuum tubes, which is a little bit like an incandescent light bulb. And then finally, somebody invented this thing called a transistor. Now, over time, transistors shrunk in size. Originally, there were thousands of transistors in a computer, and then finally millions, and now billions of transistors that are put on a chip that is roughly the size of a stamp that would fit on your fingernail. So let's find out a little bit about this thing that we call the transistor. So we need a constant flow of electricity that comes in here, and then that electricity is going to be passed through the transistor itself. Now the electricity wants to go to ground, which is labeled down here at the bottom, or the electricity can flow to some output here. Now this is the transistor. This is the collector, this is called the emitter, and this is called the base. And I'm also going to draw a line into the base where we can control the flow of electricity that is coming into this transistor. There is a constant flow of electricity that is coming from here. Say, for instance, your computer is plugged into the wall or it's hooked up on your battery. That flow of electricity comes in through that source and it wants to cross this transistor, but there is a gap right here. And as a result, the electricity cannot cross the gap. Therefore, the only option is that it has to go to the output. The reason why electricity wants to go to ground and not to the output is because ground is the path of least resistance. It's the idea that the tiny little birds can be standing on the electrical power lines and not get electrocuted. Because the path of least resistance for the electricity is along the power line, I would think it would be up one birdie foot, through the birdie and down through the other birdie foot, electrocuting all the little birds standing on the line. But there's actually more resistance for the electricity to travel up through the bird than it is to just travel along the electrical line. And the same is true of our transistor. The path of least resistance for a transistor is for the electricity to flow to ground. There is resistance for the electricity to flow to output. Therefore, given its choice, it would choose to go to ground rather than through the output. So a beautiful thing about a transistor is this input. If I put a current across the input, it allows that electricity to flow across the gap. So let's say, for instance, that I have electricity coming in from the constant flow. It travels down, it can cross the gap, and it can go to ground. If I were to draw this out as a truth table, I'm going to put an input on the left-hand side and the output on the right-hand side. In its natural state, with no electricity on the input, the constant flow of electricity is going to pass to the gap. It will not be able to cross the gap, therefore it's going to have to go to the output. I'm going to indicate that as a 1 on the output. But we can see if I put a voltage across the input, it allows the electricity to cross the gap and go to ground. Therefore, it is not going to the output, so I'm going to indicate that with a 0 on the truth table. When I first started teaching this class years ago, I used the example of the gap would be closing. If we put a voltage across the input, it would close the gap. And I had a lot of electrical engineering students that were going crazy because we know that those gaps does not close. There are no moving parts inside of a transistor. And so I changed my analogy to the idea that when I put a voltage across the input, it allows the little electrons to leap across the gap and go to ground. That also drove the electrical engineering students crazy because they didn't see the little electrons leaping anywhere. So I had a student that gave me a 15-page paper on exactly what was occurring inside of the transistor. And the best way that I can explain it is we know that oil will float across the top of water. And so when I put a voltage across the input, it allows the current to, in effect, float across the top of that gap and go to ground. So we can use transistors to control the flow of electricity.